Our question states the following. A box contains 2 coins. A regular coin and 1 fake 2-headed coin. I choose a coin at random and toss it n times. If the first n coin tosses result in heads, what is the probability that the n+1 coin toss will also result in heads? Now, let's see what our question asks for. We must find the probability of heads in the n+1 toss given that the previous n results were heads. Hn+1 is the set of outcomes with heads on the n+1 toss. Hn is the set of outcomes with heads in the first n tosses. Thanks to Bayes' theorem, we have the following. Let's use the intersection form of the numerator. This intersection can be interpreted as the set where all n+1 tosses are heads. But if I ask you the probability of getting n+1 heads, you may answer that it depends on the coin we are using, the fair coin, or the double heads coin. Let's take a look at a Venn diagram. The orange part is our intersection. Part of its outcomes comes from the fair coin, and part from the double heads coin. In other words, the probability of our intersection is equal to the following equation. In order to simplify our notation, let's call our intersection H-all. Note that our equation can be seen as the law of total probability, and as such, we can rewrite it as follows. Since each coin is chosen at random, their probabilities are 1/2. The probability of H-all given a fair coin can be read as the probability of n+1 heads out of a fair coin, which is 1/2 to the power of n+1. The probability of H-all given an unfair coin can be read as the probability of n+1 heads out of a double heads coin, which can only be 1. Now, we can rewrite our H-all equation as follows. Let's update our main equation. Now, let's find the probability of Hn. Note that part of the Hn outcomes comes from the fair coin, and part from the double heads coin. In other words, the probability of Hn is equal to the following equation. Note that our equation can be seen as the law of total probability, and as such, we can rewrite it as follows. The probability of Hn given a fair coin can be read as the probability of getting heads in the first n tosses with a fair coin. The question mark on the n+1 coin toss can be either heads or tails. It means that we have 2 possible outcomes. The sum of their probabilities is the following. The probability of Hn given a double heads coin can be read as the probability of getting heads in the first n tosses with a double heads coin. The question mark on the n+1 coin toss can only be heads, revealing 1 possible outcome. Since a double heads coin can only show heads, the probability of this outcome can only be 1. Now, we can rewrite our Hn equation as follows. Let's update our main equation. 1/2 can be written as 2 to the power of -1. Here we have a solution. But if you don't like the -n as an exponential, we can work on it a little more. There we have it.